Hi there, and welcome to my relaxing introduction to C. I know learning a new language or learning to program in general can be quite a stressful experience, and I hope with this video I can make it less of a stressful experience. Here are the topics I'll be covering over the course of this entire video. I have some things that I've excluded, but this should give you some good grounds to get started with programming with C. And just as a reminder, this is a beginner friendly introduction, so if you're more advanced, it might be a bit annoying. But if you're completely a new beginner programming, or you're really haven't touched low level programming languages before, this should be a good introduction for you. So let's begin. To start our journey, we're going to be looking at this terminal. Now, don't worry, if you've never seen a terminal before, this is just another way to interact with our computer. And if you're very familiar with these, don't worry. All we're going to do is we're going to create our first C program. And we're going to call it main.c. And your C programs are going to always end with .c. And now we're going to go into the file. Okay, so I'm going to begin by showing you the Hello World example. Now, what is Hello World? So it's a kind of a joke within the programming community that when you're testing out something new, you can do a Hello World example. And this is just outputting Hello World back to the user. So let's do that right now. Okay, so what did I just write here? So let's start off with the top. This line up here, hashtag include standard.io.h. All this is saying, hey, I know someone else has written some code and I want to be using that other person's code. So let me include this inside my program. Now, what is this int main? Now, int main is where your program will begin executing, where the hashtag include is the precursor to this, or the preprocessor as we call it, and this will grab the code and get everything ready for us. Int main's where we actually start running our program. Within these curly braces, we can see that we've got some code here as well. Printf here is a function that we've taken from the standard library above. And all this is going to do is output hello world back to our terminal. And this is an old convention here, return 0. And why return 0? It just tells the operating system, hey, this program successfully finished. So let's run this program. So we're going to be using GCC to compile our program, and we're going to put in main.c as our file and then output it as main. So let's run it. And as you can see, we have our hello world example. So here we have a visual example of what's going on. And with our precursor, it's almost like we have untied shoes in a race. And all our precursor is going to do is tie up those shoes for us, so that we're ready to start our program and start running the race. Next, after we've tied up our shoes, we have the main, which is a bit like the start line to our program. And then once we start running our code. And then once we've run our code, we end up at the finish line. And this is a kind of visual idea of what's going on with the last program we wrote. So, before we get into variables, I wanted to show you an example. So, here's a variable declaration here. So we've got a data type, in this case it's an integer. We have a name, in this case it's age. We assign the variable a value, in this case it's 21. And this is analogous to creating a box with the name age. A box can hold different things inside it, and the type of box will have the different types of values we can store like an integer. We're going to take the value 21 and we're going to throw it inside of our box. And now we have a box called age, or a variable called age, with the value 21 inside it. Again, we can have different types of boxes, and this one just so happens to count integers, but we'll get onto that shortly. Okay, welcome back. And now we're going to talk about variables. So let's reopen our previous program. And let's delete our old code. We don't need that anymore. So within C, there are three what we call primitive types of variables. Okay, and I'll show you examples of all three. First of all is the integer. Now, age is a perfect example for an integer, and the reason why is that these are counting numbers. And what exactly is a counting number? Well, it's any number that you can count with your fingers, okay? And these can be positive or negative numbers. We also have characters, which are typically used to store characters, so your keyboard characters, for example. And this follows the ASCII format. Now, if you don't know what ASCII is, don't worry. All it is there's a standard where we've used particular numbers to represent letters, and also numbers to represent numbers and symbols. I'll bring up quickly an ASCII table so you can have a quick look at what different numbers represent different symbols. So next we have floats. Now, floats are fractional numbers, and we could have something like our wallet that could have maybe 50 pounds and maybe 25 pence. And these can be positive and negative as well. So this is the three primitive data types or variables that we can have in C. Now, why do we use variables? Well, sometimes we want to give names to our data because it can be pretty hard to keep track of what our program is doing when we can't name what the data is. So this is why we use variables. And we can do all kinds of arithmetic operations on them, but we'll get to those in a second. There's also different variations of these variables. So for example, with the integers, we can exclusively make integers only give us or only store positive numbers. And we can do this by saying it's unsigned. Now, in the case of students, you can't have a negative number of students. You could only have 0 or a positive number. And that's where unsigned comes in. And essentially what we're doing is, with a normal integer, we'd have a plus here or a negative here. And that is a sign. And when we're saying unsigned, we're essentially taking that sign away and make it so it's only positive numbers. Also with integers, we can also make shorts. So with shorts, we do a short, and then maybe we do people. So this is literally just means that we're storing less space. So in the case with a short, it's 2 bytes minimum. With an integer, it's 2 bytes minimum as well. And then we have the long, which essentially is 4 bytes. So we could have trees. And this would be 4 bytes long. Okay. Now, for the most part, you shouldn't really be too concerned about the sizes of your variables. Only when there's specific applications that require you to use longs, you should use them. But for the most part, for your application, you want to be using the smallest size variable that you can. And this is just for efficiency purposes. So if you're confused about these bytes, don't worry. Basically means if we have a larger number of bytes, such as long, we can represent a larger range of numbers. And if we have a smaller number of bytes, such as a short, we can only represent a shorter range of numbers. In this case, it would work on 2 to the power of 16. And the details of this, you don't really need to know. And of course, with these shorts and longs, we can also make them unsigned. Which basically means, hey, we only want positive numbers. So let's get rid of all this code. It's starting to look a little bit messy, and I apologize. Again, with characters, we can also have an unsigned character, which basically means we only want positive values of characters. And again, characters only can store 1 byte of information. So there's a lot less in a character than in an integer, for example. And finally, with floats, we have 3 different versions of float. So float is the smallest one, right? As we can represent the smallest number of fractional numbers with just the float. The second one is the double. This is 8 bytes. Let me just clear this up. And a float is 2 bytes. And finally, we have a long double. And this can store 10 bytes. And again, just to remind yourself, the more bytes we have, the larger the range of numbers. So by range, we mean from negative x to positive x. So hypothetically, this might be negative 127 to 128. For example, I think it's in real life it's actually like this. Okay, but that would be for the case of integers. And floats, it's a little bit of a different story, and I will make a video explaining the intricacies of floats. But for now, all you need to know is that they store fractional numbers. So now let's do a practical example with variables by using arithmetic. So let's say, for example, that we have a bank account. And we have £50 in that bank. Or rather, £50 in our wallet. And say for the week we have our wages. And we get £3 for our wages. We're not making a lot of money. And we want to put that money in our bank. So we're going to say, hey, let's take our wallet and let's add our wages to it. And the addition is always signified by plus. So we'll just shove this up here to tell us that, hey, we're doing an addition. Cool. And if we were to print this back out to this screen, we could go and use printf again. So we can say our bank account, our bank account has 53 is the output that we expect. So let's go try this out. And there we go, £53 in our bank account. And just as a heads up, if we do \n within printf, this will just basically tell us, hey, let's print a new line. So it's the exact same as pressing enter on your keyboard to do a new line, like here. Just keep on pressing enter, and that's the same as \n. So let's do an example of a negation. How do we subtract values from our variables? So let's say we've got some taxes. Nobody likes taxes. And say our taxes are £5. So what we're going to do is we're going to take our bank variable and we're going to minus £5. Damn, that's our taxes. But there is a shorthand for this, especially when we're self-referencing this variable. So we see our bank has got our £53 in it, and we say, well, we're going to take £53 and minus the £5 to give us 48. Okay. So there is a shorthand for this that we use in programming, which is negative equals. And that is the exact same as doing bank equals bank minus taxes. So we're going to use that instead. We can also do this for plus, and what we'll see in the future is multiplication and also for division as well. So let's print out our new bank account balance after applying those taxes to it. That should be it. Okay, so what we have here is, I think I have put the, yes, I accidentally took away the the negative from the taxes here. So let me reintroduce that there. So now, just to make sure, we're taking our bank minus our taxes and putting it back into the variable bank. So let's run this. And there we go. There's our 48. Now this is starting to look messy again, so let me clear this up for you. And let's go back into our program. So that was our negation. Cool. Alright, let's go to multiplication, and hopefully you're starting to see a trend here. So let's say we wanted to find the area of a room. Okay, so back in math class, we had our breadth, which we're going to say is 50, and we had our width for our room, which we're going to say is 30. Okay, and this could be any unit at all. And let's say it's for meters, for example. It's quite a big room. And we're going to say our area is equal to breadth multiplied, which we use our star, width. There we go. And let's print this out to our terminal. Okay, and this will print this out to our area. Now again, I probably missed this earlier on, and you might be a little bit confused by this symbol here. So all this is saying to us is, hey, I'm going to put a variable inside this text, and the variable is going to be type decimal or integer. And then once we finish this string, we're going to plop in whatever variable we want here, and that's going to pass it and shove it into this piece of string here. Nice and simple. So let's see how this runs. So let's compile it again. Ooh, we have an error. Ah, I said breath instead of breath. 2 seconds. There we go. That should fix our error. Clear and run. And this will happen when you're programming, right? You'll have some errors that pop up and you're going to need to fix them. That happens all the time in programming. So let's go run our program again, and we should see our new area of the room, which is correct. Sweet. And finally, let's finish this off with the last 2 operations that we're going to be covering today. So the next one's division. And let's say that we have a crisis on our hands. So let's say we've got a population. And let's say that we have an epidemic. And we say that 23 people are infected. And we want to know the percentage of people that are infected. So we're going to use a float because percentage can have fractional numbers. So we're going to take our 2 integers and we're going to divide them. Now, there's something important that's happening here. Is we're taking 2 integers here, infected and population, which are both integers, and we're storing them inside of a float. Now, this can be done, but what's going to happen is we're going to lose something called precision, or we're going to lose some data. Okay. We're going to do 23 divided by 5,000, but we might lose some information, and why is that? Well, it's because we're dividing 2 integers, and integers cannot store those fractional numbers that we're talking about. So in order to solve this, we can convert one of these variables, which is called casting, into a float. Now infected will have the same data as 23.0. Now, when we do this division with a float and an integer, what C is going to do is essentially keep the float format and do this division as if we were dividing by 2 floats. And this will give us the correct percentage. So let's see how this prints out. Again, in this case, we're going to insert a variable that's going to be type float. Do \n and then put in our percentage. Let's clear this up, compile the code, and run main. And as you can see, we have 0.46% infected. Let's just make sure that's correct. And yes, that is correct. finally, we're going to talk about one of the slightly more different operations you've probably never seen before. Let me just put that in there for you. So this one's called modulo arithmetic. Now, what is modulo arithmetic? So, do you remember when you were dividing back in, math class, high school, college, and you had remainders? For example, if we had 12 divided by 5, well, 5 goes in 12 two times, and we have a remainder of 2. All the modular arithmetic does is keep that 2, and it will tell us and store it in a variable. So let's try this out. So we're going to say we have some students, and we have 13 of these students, and we have, say we want to group those students into a group of size 3. Perfect. And we want to find out how many students aren't in a group, because we're dividing by 3, and we want to see, hey, who's left over, who's not a part of a group. So we're going to say remaining students, and that's going to be equal to students module group size. Perfect. And remember, it's just giving us the remainder. So let's print this out. So let's say we want to print out the number of students here, and also the group size. And also the remaining number of students. Perfect. Now, let's see what this prints. Oops. And as we can see, we have 13 students, group size of 3, and the remaining number of students left over without a group is 1. So that has been variables and arithmetic in C. Alright, welcome back. And now, we're going to be talking about if statements. So what exactly is an if statement? Well, what we'll do is we'll have a quick example based on the previous example that we had with students and group sizes. So let's recreate that example. Okay, so we've recreated the previous example with students and group sizes, and we've got the odd number of students, right? So if we don't have a perfectly dividable number, right, that divides nicely into 20, then we'll get an error. So what we're going to say is if our odd students is equal to 0, and 0 with modular arithmetic basically means there's no remainder when we do the division, we're going to print out to the user and say, hey, perfect, group size. Brilliant. And then we're going to say else. If this is not the case and we do have students that are left out, we're going to print if and say bad group size. I'm going to create a new line and say to the user how many students are left over, and we're going to do that here and say odd students. I think I missed there we go. Cool. So let's give this a wee shot. Compile it and then run it. And right now we have the perfect group size. So let's change this code so that we don't have a perfect group size. So I think 3 will give us this. And there we go, we get bad group size. Leftovers too. And we've got a wee space there by the leftover, don't worry. That's just some formatting we've done with the string there. And also there's one other thing that I want to mention with if statements is we can also do an else if statement. So hypothetically, you can write here as well, else if odd students. Well, let's say we don't mind if it is we have odd students greater than say 2, right? Because if we have more than 2 as a remainder, then we can say, well, it's not terrible, but it's good enough. Okay. We can let those people in inside of our group. So what we're going to do is we're going to also write in here an else if, print if. Not ideal, but it'll do. And I'm pretty sure if we put this up to 7, this should give us the decent or correct output that we're looking for with there. And there we go. Not ideal, but it'll do. I want to erase that else if in the middle there, because I also want to give you another example of a conditional statement inside of the if statement. So we can also do operators inside this as well. So we can say, well, if odd students is 0 and that the group size, and we represent ands as with 2 ampersands in C, and we say the group size is greater than 5, which means that we are looking for no students left over and we need our group size to be greater than 5, so 6 and up. So that's what we'll do. And then we'll print off perfect group size if that is the case. Else we'll print off bad group size. And just to reiterate, I might have skipped over this, but that's okay. Greater than uses the right arrow here. Less than is the left arrow. And we can also do equal to. So we could say also equal to there. Less than or equal to. Or greater than or equal to. I should have mentioned that earlier on, but I'm mentioning it to you now. So. And if we ran that, even though we have a perfect group size with 4, we will get bad group because we're looking for specifically a group size of greater than 5. If we change this to an or but though, this means that, hey, if we have 0 for the leftover students, then we're saying that's a perfect group size, or if the group size is just greater than 5 anyways, then we have a perfect group size. So we'll go back to that 7 example, and what we can say is that we're not going to have the perfect division for 7 into 20. So it's 7, 14, and then it's 6 left over. But because our group size is greater than 5, we're just going to print out perfect group size. So let's do that. Perfect group size. And that's if statements. Okay, so the next topic is arrays. So let's go back into our main program here. And let's delete the old code that we had here. Perfect. Okay, so let's say for example that we were working out and we were doing daily runs and we wanted to track our daily runs. And we were taking the records for our runs. Say for example if we did it for 11 minutes one day, then 10 minutes the next. Let's write this out in our conventional means. So we say record day 1, and we'd say that would be maybe 11 minutes that we managed to get in. Record day, and then we said maybe it was 40 minutes next day. Record day 3, and then this was maybe 30 minutes, and so on and so forth. But can you see how cumbersome this is to write all this data out? Isn't there an easier way to write this out where we can just say, can I just get the records all in one place, and if I need a particular one in it, can't I just choose one in that one structure? And yes, and it's called arrays. So what we're going to do here is we're going to rewrite this code to be a little bit nicer. So we're going to create an array of integers, and we're going to call it a tracker, and this is going to track our daily runs. And within arrays we can just say, hey, let's put a bracket over it to represent an array, and say that we wanted to store 11, 12 minutes, 9 minutes, 40 minutes, and also 50 minutes. We use these curly braces to initialize arrays as well. So also, because we have 5 elements in the array, we can also say, hey, let's set aside 5 elements or 5 areas of storage for our array. So we have 11, 12, 9, 14 and 15. And how this will look like in the computer is a bit like this. So we have our 11, our 12, our 9, our 14 and also our 15 stored like this. So how do we access this information, right? Because now it's all in one variable called tracker. Well, we can still use the brackets here. So like 0 will give us 11, and 1 will give us 12, and so on and so forth. And we'll quickly just write the positions here, just so you get a little bit of recognition about what's going on here. So let me just try to reformat that. Here we go, that's better. So we've got 0, and we've got 1, 2, 3, and 4. And these are just the positions, okay? So if I did tracker, and I did brackets 2, this would be the same as equaling 9. And if I wanted to get the last day, which is the 5th day, I just put 4 in here, and that would be equal to 15. So you're probably wondering why this starts off with 0. And what you'll find out with most programming languages and most concepts in computing, we start indexing from 0, just because of how binary works within computers. It's just more convenient to run 0 as the index. So can we do something more interesting here? So for example, what if we wanted to change the first day because it was wrong? We can absolutely do that and say tracker, and we'll say the first day, which is indexed at 0, and we want to make this equal to 9, or 8 rather. There we go. So now our first day is 8. What if we wanted to use it in something? So we could do print if, and we could say, well, day 3 time, and then we could put in here tracker, but day 3 it should be 0, 1, 2. Oops, forgot to add that, and then that will output the 3rd day for our running time. So let's give this a wee try right now.
let's compile the code and then run main. And day 3's time was 9. Let's go check that again. And yes, indeed it was. And what if we wanted to change day 3? And we wanted to change it to 13, for example. We could go G. Oh, I think I did something wrong there. Yes, I did. It was supposed to be 2. So let's do that instead. So let's compile that code, go back to main, and then as you can see, we've changed it to 13. So there's something interesting about arrays as well, is that once you create one, you cannot add more data onto it. It's a fixed size. So there's a few things to get around this. One is that you create that your tracker's so big that it can store as many elements as you want. Say for example like 1,000, and maybe 1,000's good enough for what you need. So then you could just keep on adding onto tracker. So they got tracker day 6, then day would equal say 23, tracker day 7, and so on and so forth, right? But your computer only has so much memory, and that's not always a great idea. So what would we need to do in order to add, say, an extra element onto our tracker here? So I'm going to just undo some of the code here. There we go, and let's return back to the tracker 5. Well, there is a little bit of a more complex problem here, right? So what we need to do is copy all this information and put it back into a new variable, which we call maybe tracker new. Align that with 6 elements if we wanted to add an extra one, and then shove all the elements from tracker into tracker new. And how would we do this? Well, there's kind of a little bit of a cheat way to get this done by using another library, but we can also do this with loops as well, okay? But I'm going to do this using another library or another person's piece of code. So I'm just going to include 2 libraries here, string.h as well. And there's a function here called memory copy, and we're going to copy the memory from one of the arrays, and we're going to store it into tracker new. Say that we're going to take the data from tracker, store it into tracker new, and we're going to say that we have 5 integers that we want to store. So we're going to do size of int5, and that will copy it into tracker new. And then what we can do with tracker new is add our new date onto it. So we can do 5 here, which would give us the new date that we want to add onto it, and then say this would be 19. Say we did a really good day on the last day. So this would create a 6 element array instead of the original 5 element array that we had before, and then we're going to store 19 into it. To show this in action, what we could do is say tracker indexed at 5, which would throw us an error, okay? Because we only have 5 elements in tracker, and if we try and index to 5, that's the 6th element in the array, starting from 0, that would throw us an error. So if we do tracker 5, that should throw us an error, okay? So let's compile that code, and oh, tracker new is undeclared. That is because I forgot to add the integer here. Of course. My apologies. Okay. And as you can see, tracker index of 5 gave us a completely random number. And as it should. It's because we should not be able to index 5 for tracker. And actually, what it is actually doing is that when we store this information, there is other data over here, but we've not assigned it any information, so it could be anything. And like we saw with the output, we got something in the thousands, which isn't correct. But if we have a look at our tracker new variable or array, we should see 19. And as we saw here, we've got 19. But again, with arrays, you shouldn't really be too concerned with trying to add extra elements. There's other data structures and other ways to do this in a nicer, neater way. But for the time being, this is one way that you can copy an array and add elements onto it. Alright, so to give you a quick example, we have our array here and the declaration of an array, and we have a type integer. Here we go, that's our data type, and we also have the name tracker for our array. We also have 5 elements that we're going to store in memory, and we're going to do that right now. So here we go. So we're going to store the first bit of memory, which is going to be 0, the second, the third, finally the fourth, and the fifth. So these are just squares of memory. Okay, so next we're going to place the values into these areas of memory. So here we go, here's our values right here. And we have the value 9, which we're going to store in the first index, or index 0. 11 for our 11 minutes in our tracker. 10 for 10 minutes in the second position, our second index. 14 in the third index. And 19 in the final one. So this is our array, and it's how it's stored. And as you can see, they're stored right next to each other. And there you go. There's all the values in all the right places. And just a final note, you can't store anything at the end after the 4 because there's nothing allocated. So that's arrays. Okay, welcome back. And now we're going to talk about for loops and while loops. So, where do we use for loops and while loops? So, for loops and while loops are used when we need to do something over and over again for a number of times. Specifically, while loops are used for when a condition needs to turn false, but we don't know how long that's going to take. Whereas a for loop, we typically use when we know how many iterations we need. So for example, we need to do something 5 times, then we use a for loop. But if we needed to know when we reach the end of a file, which could be any size, we would typically use a while loop. So let's give a quick example of both. So I'm just going to do a very basic example here. So say that we have a counter, okay, and the counter's 10. And we're going to say while, oh that's not as tidy, so while our counter is greater than 0, which means it's still positive, we're going to print out counter and also the value of counter as well on a new line as well. And then output counter. And then we're going to decrement our counter by minus minus. And now minus minus is the same as doing counter minus 1 or minus 1 counter. So if we do counter minus minus, we're just minusing our counter by 1. Now let's see this in action. So let's go back and gcc main.c, output this to main and run main. And as we can see, we've done the loop 10 times. And then once it hits 0, we stop execution. Now there is another loop called the do while loop, and it's very similar to the while loop except for we run it at least one time. So if we do a do while, we do we could do the exact same program, right? But we're going to do this at least once. So, and the perfect example for this, we're just going to do counter, and then we're going to display our counter. And then we're going to do counter minus minus. And then all we need to do here is our while, and then say while counter is greater than 0. But let's say that our counter was already negative, or less than 0, or already equal to 0. Okay? What happens now? Well, with a do loop, it runs this at least once, then checks the condition. So if we set counter to 0, what we expect to happen is that this printf will run, whereas in the other while loop it wouldn't. So let's give this a wee shot. Main.exe, and there we go, we can see the counters there. So that's just another, we don't use do whiles that often. Sometimes they're really useful, sometimes we don't really need to use them, but again, it's there if you need it. And next we're going to do a for loop. So say we wanted to print hello world 10 times, okay? We could do this with a for loop. So we're just going to say for, and then we need to define an index, or define some sort of variable to keep track or increment over the for loop. So we're going to say index in this case, okay? And then we're going to say while our index is less than 10. Oh, I also forgot, we should probably give this index a value. Okay, so index is equal to 0, and while index is equal less than 10, we're going to increment index by 1. So what this is going to do, it's going to start off with 0, run this code, and then increment to 1. And then it's still less than 10, so it's going to run this code, it's going to increment to 2. Then still less than 2, run this code, increment to 3, still less than 10, run this code, etc, etc. So print f, and then we're going to do hello world. So we're going to expect this to run 10 times. CCC and main. Hello world again. I forgot to use the backslash, but that's okay. We're just going to implement that right now. And there we go. Hello world 10 times. So that's while loops and for loops in C. Okay, so I wanted to give you a quick example of the for loop again, just in case it wasn't clear in my last explanation. So we have a program here with our tracker, the values in an array. We also have a for loop here, initializing I to 0 and doing it 5 times. We're going to take out the time from the tracker, and then we're going to output it to the terminal. And then that's the end of the loop there. And here is just another view of the tracker there, just for us to have an easy view. So let's begin. So let's create the tracker array, start the loop. So I is going to begin at 0 because it's less than 5, so we're going to let I equal 0. Next, we are going to assign the value tracker 0 to time, which has the value 9 within tracker. So time has now got the value 9, and we're going to print that to the terminal. So here's our wee terminal over here, and we're going to grab the value 9 and output it. So we reached the end of the loop, but we've not finished yet. We need to check that I is still less than 5. Yes, it is, so we're going to keep on going. Okay, so I is now equal to 1, and again, like before, we get tracker, and we find the position of 1 within the, or the second position, which is 10, and then put that into time and print that out to the terminal. Again, we reach the end of the loop, we increment I to value 2, so to get the third position of tracker, and once we do that, we can store that into time and then print it. So that's a value of 11. So we're going to go out and then output value 11. So we reach the end of the loop again, still less than 5, so we're going to increment I. And now I is equal to 3. Brilliant. So now we need to get the fourth position in our loop, which is here. So int time, and we're getting the 4th position, which is 14. And we're going to print 14 back to the terminal. Hopefully you start to notice the trend here. And then we need to increment one more time to get I to 4 before I equals 5. So there we go. I is equal to 4. Now we get the final 5th position in tracker, which is the value 19. We're going to store that in time and then print it back out to the terminal. And there we go. All our values are printed out. We reach the end of the loop. We start again. We check that I is now less than 5. I will now equal 5. So we can take 4 i's away from there, and then we can reach the end of the loop and we skip the rest of the code. So this is our terminal, and I missed the new line character, but I think you get the idea. So that's loops.
Alright, welcome back. And now we're going to be talking about functions. So let's begin. So what exactly are functions and where do we use them? I'm going to give you a quick example of a situation where functions come in handy. And that is when we... Oops. There we go. When we need to get the power of a value. So, as you know, within C, the primary arithmetic methods that we can use, or operators rather, is add, minus, divide, multiply, and the modular arithmetic. Now that we have these basic operations, we can pretty much do any type of mathematics that we want to do. Powers is not included by C in default. I know in Python it is. There is a shortcut to this, where we can just do hashtag includes math.h and we can get a function readily made for us that already gives us the exponential for a number. But we're not going to do that, we're actually going to create our own. But before we do that, we're going to test out our code in main and not actually put it into a function just yet. So we're going to create a value that we want to get to the power of, which say like 2. And then we want to give to the power of, say for example, 8. So we were going to try and calculate 2 to the power of 8. Okay, and I think that's the symbol of it. So it's just going to be 2 times 2 times 2, 8 times. We're going to have to restore the result in a variable, so we're going to put result equal to 1. And we need to do a for loop. Okay, so what we're going to do is we're going to just have a for loop where we have an index, which we're going to say is I is equal to 0, or a counter rather, however you want to call these variables within the for loops, it's up to you. So you're going to say while I is less than power, do I plus plus. So we're going to do this 8 times. So result is going to equal result times value. Okay, and that's it's just going to be the same as times by value times by value times by value, and again we can make the shorthand for this, which is multiplied by equals, and then we're going to print this back out to the display. So let's go do that right now. So we're going to say the value to the power of, and then we're going to say power is, and then we're going to say our result here, and that should be that. So we just do value, power, and result. So let's compile this code and see what the output is. Oh, I think I did a colon here instead of a semicolon. So let me change that 2 seconds. And so let's compile our code. GCC main.c taco main taco main.exe. So we've got here 2 to the power of 8 is 256, and I've got a wee calculator here, and yeah, indeed that's 256. So what if we wanted to do this again, right? Say we needed to do the power of multiple numbers. Well, in the current method that we're doing this in right now, we'd have to copy all this code. So let's actually do that. And just to highlight the fact that this is going to be a lot of code, so I'm going to yank this code off, and we're going to change the numbers here.
So we want our value to now be, instead of 2 to the power something, we're going to say integer, no, it's not integer, value equals, say, 3 to the power 5. And let's rerun the code. But first, before we do that, we need to add a new line to our print statement, just to make sure nothing is going to look weird. Okay, that should be us, so let's compile the code and run it. So 2 to the power 5, yes indeed, is 243. But that's fine that it works, and if you're happy with that, that's cool. But can you see how many lines of code this took to make? Isn't there an easier way to do this, where we can just call a shorthand to do a very complex mathematical thing for us? And yes, we can create it and put it into a function. So let's do that right now. Let's get rid of all this code. So first of all, before we get started with creating a function, we have to give our function what's called a prototype. And a prototype is just telling C that, hey, I'm creating another function, I would say, or another piece of code I'm going to reuse. But I might have not have created it when I'm using it. So I'll explain what that means in a second. So we're going to say int, and we're going to give our function a name. So exponential. Yeah, I think that's how you spell it. And we're going to pass a couple of parameters into our prototype. So we're going to say integer, and we're going to take a value. So what all this is going to do is going to, whatever value we give to our function, it's going to make a copy of that value so we can use it. And we're also going to use power as well. And at the start here, we're just going to say return an integer. So, and this is the name of our function, and these are it's kind of like a list of parameters we're giving our function. So we're going to copy some values and send it into the function. So let's start creating it. Again, when we actually create our function, we have to follow what the prototype says. So we're going to create a function that returns an integer. We're going to give it the name exponential, and we're also going to pass 2 integers into it. Now these integer names don't have to be the same variable names as the ones you passed in, and then I'll show an example. It could be int v and p, and of course in the prototype as well, these names could be anything as well. As long as you're passing in 2 integers, it doesn't really matter. But for readability's sake, we're going to copy the same variable names. But just know that these names could be anything, as long as they're 2 variables. So what we're going to do in here is we're going to create our result variable. We're going to say it's 1, and also do that for loop that we have above, which is going to be int equals 0, I less than power, I plus plus. And then finally, we're going to multiply our result by the value. But because we gave the function a data type that we're saying, hey, we're going to actually return a value from this function, we also need to return our result back. Okay? So let's see this in action. So we're going to take away all this stuff. I'm going to take away the result as well. And we'll keep result for the time being. So result equals, and now we can use our function. So exponential value and power, and we can pass our variables in here. And remember, we're passing in the value of the variables, not the variables themselves. So if we went into the exponential function here and we changed the value of value, I guess, to say 5, 4, this value in main will still remain to be 2. We've just changed it inside of the exponential. We've actually created a new value, a new variable called value. And again, this harps back onto the fact that we can call these any variable we want. We're creating 2 new variables that just have the same value, but they're not the same variables as the ones up here. So just keep that in the back of your mind. So we've copied 2 values, and we put them into our function, and we're going to call it. So we go to result equals 1, we do the for loop, we do 2 to the power 8, and then we're going to return that value back to here, so it's 256. So 256 is going to go back into our result, and then we're going to print it out just like before. So let's see this work. Oop, we've got a wee issue here. So it's undeclared, and that's because I never gave it a name, and that is my bad here. Again, in programming you get this all the time. So GCC, and let's run our new piece of code. And like you can see, it's the same thing, but this time if we wanted to do the same thing, we can do it in less lines of code. So let me just go to the end here and copy these 2 lines of code. So I'm going to yank these away, go into a new line and paste it, and show you that we could change the value to something like 3 and do the power of 5, and we could also do the same thing, but now it's only an extra line of code to change that result. And also we need to take the integer away from result because we've already declared it. So let's see how this works. And there we go. And of course what we'd have to do here is change the value here to 2 and here to 5. I was 3 and 5, so I was wondering why the output was slightly a bit weird there. Of course we're not using the same variables anymore. But what if we never wanted to return a value? Say we just wanted to do this print out statement, just like there, because I clearly forgot about the variables. So what happens then? What if we don't want to return anything from our function? Well, we can change this into a void function. And remember that this could be a float, it could be a double, it could be a car, it could be any type of data type that you want. But if you don't want a data type, you could give it void. Now that we have void, it means that we're not going to return anything, so we have to get rid of that return statement. But say if we just wanted to print out the value that we were going to calculate. So let's copy this line of code here. And then paste it to the bottom of our new function. Now we can get rid of most, if not all, this code in main and just leave it with the exponential. And do you see how much cleaner our code has now become to do the exact same thing? Say we wanted to do it to the power of 10, exponential, say 5 to the power of 2. Okay, and if we just run this right now, I was expecting an error to come up. Must have misspelled something here. Nope. Because we changed our function here to a void, we also need to change our prototype as well. That is my bad. I'm making a lot of mistakes today. Apologies. So let's recompile the code. Let's clear this up for the time being and bring out main. And as you can see, we can now do the exact same thing in a few lines of code. Of course we made the lines of code at the bottom here, but when it comes to actually using them, it's just one simple line of code. And again, to remind you, these parameters that we make here and in the prototype, they're just copies of 2, 10, you know, where 2, 10, we're just copying them over and creating 2 new variables called value and power in here and using them there. We're not getting direct access to the values themselves. We just got a copy to them. So that's functions in C. And we'll move on to more involved example once we get past pointers, which is the next topic. Okay, I'm going to give you a quick example of what pointers are. To the left we have a program, and to the right we also have our memory in our computer. Now, what we have here is you can think of memory like a big array where you have addresses and values. So, and also like an array you have your indexes. That's a bit like your address, okay? And here currently we have address 0 or index 0, it's got no value, 1's got no value, and also 2 has no value, and this continues on and on and on, as you can see here. So again, this is what our memory is. We have addresses that are associated with values. So let's have a look at this program I've written over here. It's a very simple program, and what we're going to do to start off is we're going to create a normal variable, just an integer. It's going to be called age, and it has the value 21. So I'm going to show you what that looks like in memory right now. So we're going to go to our memory, we're going to look at the first available address, which is 0, and we're going to put the value 21 where 0 is. So as you can see, I'm going to shift over here with age, and age is now equal to 21 in our memory, and that's where it's stored, so we can access this later. Okay, and it's at position 0. So next, if we want to get the address of age where it's stored in our memory, we can do ampersand age, and that will give us back 0 in this case, okay, because it's stored at position 0. Next, we're going to create a new thing, so a new data type, which is called int star. And we can do this for float star, double star, basically means that we're creating a pointer. And what we're doing with this pointer is we're going to store the address of age. So it's just a variable that stores the address. It's going to be storing the value 0. So here we go. Here's our pointer, and it stores the address of age, which is 0. So we can do something really cool with this, which is called dereferencing. So if we do star pointer, what this will actually do is say, hey, what value does pointer have? It's at address 0. So let's look at address 0. Okay, what value is at address 0? 21. And what this will do will actually retrieve the value 21 for us.
Okay, here's another reprogram here as well, just a continuation, just to cement the idea. We've got a pointer, we're dereferencing it, and we're assigning a new value 25. So what does this actually do? Well, it says, hey, let's go to our pointer, which has got the value 0, the address 0 stored in it. Let's go to that address 0 and get the value 21. And now what we're going to do is store the value 25 where that is now. So now we have age is equal to 25. And this is exactly the same as doing this. So now you see the power of dereferencing. Essentially, we're making a direct copy of the variable. Alright, welcome back, and today we're going to be talking about, I guess, one of the most infamous parts about C, and that's pointers. Now, hopefully that little introduction video kind of got your imagination going with pointers a bit, or rather your intuition about pointers being more cemented. So again, let's reiterate exactly what a pointer is. So all a pointer is a variable that stores the address of another variable. So that other variable might have a value to it. So for example here, let's have a variable, and we're saying age. So we're taking an integer, we're giving it age 21. So a pointer to age would look like this, so pointer to age. And now we're going to say is, hey, we've got this pointer that's going to point to a variable that's got the type age, int. And then we're going to give it a wee star to say, hey, it's a pointer. Okay, so it's going to point to an integer, and the value of this is going to point to the address of a variable, in this case age. So within pointer age, it's just a variable, but stores the address of age. So let's actually have a look at what the address of age is. So let's go print the value of age, so, or the address of age. So we're going to say address of age. And in order for printf to figure out that this is an address, we don't do %d, we do %p to say, hey, we're going to display a pointer. So, and a pointer is the same thing as doing ampersand age. It's just saying, give me the address of age. So, and then let's go get the value of pointer age, which should be the same thing, right? Because all the
pointer age is storing is the address of the variable age. So let's do this right now. Pointer age, and let's run this code. So let's clear this up. I was doing a little bit of testing beforehand. GCC, and then do our main function here. Okay, let me clear that up real quick for you. I keep on forgetting to do this new line character, my bad. So I don't need it there, I need it here, but I'm going to add it here anyways because we're going to do something afterwards. So clear GCC main.exe. Okay, and as we can see, they're both the same thing, right? So the value of the pointer is the exact same as the address of age. Okay. Now, why is this so useful? Again, like we saw in the example, is that we can do something called dereferencing. So what we're going to do is we're going to open up our program again, so main.c, and we're going to dereference the pointer age. So we're going to do here printf dereference, that's it, pointer age, and now this is going to be a value. So all the dereferencing is essentially, hey, I've got a memory location stored at me, so I'm going to say pointer age. So pointer age has got a memory location it's got access to, or storing, and it's storing the location of age. So all dereferencing is this wee star here, and this is saying to pointer age, hey, go to where age is stored and get me the value of that, which in this case is 21. So let's have a look at this. GCC, and then run main. And then there we go, dereference pointer age, which is 21. And we already know age, the value of age is 21. Okay, so can we alter the value? Yes, we can. So let's just copy this code actually. So let's copy this and paste it into here. And let's change the value of age using the pointer. So we can do pointer age. So pointer age, which is just saying, hey, get the value of age like we talked about before. Now we're going to set this to 23. Now this will now change the value of both the pointer age when we dereference it, but also the age variable itself. And we can see this here by printing out value of age, which we're going to have here. And D, and we're going to put age in here. And before we do this, again, I'll remember to put the new line characters in so it doesn't look like a string of characters or a big hot mess. Okay. Main.exe. And as you can see, we've changed the value of age from 21 to 23. And you can see at the bottom there, so value of age is now 23, and when we dereference the pointer age, it's now 23 as well. So why is this so useful? So well, basically when we were passing our variables into our functions, so for example our, say for example integer add, is going to add to, I know this is a very stupid example, but it's going to add two variables, a and b. Okay, just to get the idea. What we were doing with a and b, a plus b, okay, it's just a simple function. What we were doing when we created, say for example, a here, which is going to be 25, and b here, which is 12, for example, and then we did the integer value, or result rather, 25, and so a and b. Oh, my typing is not up to scruff today. Okay. So what is this actually doing right now? So it's going to take the value a, it's going to copy that value and store it into another variable a and a here. Or rather, let's do, instead of a, let's do x and y, just so we don't get confused. So these are two separate variables, and our program's actually going to create two new variables called x and another variable called y, and x is going to store the value 25 because we've put that into the add up here with add a, and a is 25, and b, which is now going to have the value so B, and then B, which has the value 12, and then that value is going to be copied into the new variable y. But what if we didn't want to create two new variables here? What if we wanted to directly access A and B? Say we, for some reason, we wanted to directly access A and B within this method, for example. So a good example of this would be if we deleted this function and we did something like, and we wanted to square x, so square. How would we do that? How would we do that without returning a value? And we just wanted to change whatever value we passed in directly, but not return anything. We wanted to directly change the value that we passed in. Okay, so let's show an example of this. So say we wanted to square, so say for example our height was for example 5 foot, okay, or 6 foot, for example, 6 foot, and we wanted to do a square, and we wanted to square our height. Okay, how would we do that without returning the value? Well, we can do that with pointers like before, so let's try that right now. So we'd have to pass in the address of height, which is basically saying to the function, hey, I'm going to pass you a pointer. So we're going to pass in an integer pointer, which is going to be some value. Okay, and then what we're going to do with that value is dereference it. So we've got dereference x, and then we're going to make that equal to whatever x is. Okay, so this looks a little bit messy because it's got these star pointers and star things. I'm just going to break it down real quick. So dereference x, all that means, or rather pointer. I think that might be a little bit clearer. So if we dereference a pointer, we're going to get the value 6, and we're going to multiply 6 by whatever is in the value pointer, which is 6. So we're going to do 6 times 6, which is going to give us a square. And right now we don't even need to return the value because we know that if we do a printf and we get the value of height, it's going to be 36. So let's do it before and after, just so I can prove to you that this is actually going to square the value. Okay, so let's try this out right now. Let's clear this out and just do the GCC. Oh, okay. I forgot to do the prototype. So void square and an integer star. Okay, so let's clear this up and run our program. So as you can see, our first value was 6. Now we squared it to 36 directly without needing to return the value itself. And this is incredibly important, and this kind of concept is called passing by reference. So we're passing a reference into our method. So it's almost like, hey, I've got the variable height, I'm going to send height directly into the method. Okay, instead of saying, hey, the value of height 6, I'm going to send a copy to the method of 6. Okay, this is an important distinction to make, but nevertheless, that is the primary basis within pointers. Okay, again, there's more complex things that we could talk about, like memory allocation and things like that. If you want me to do a video about that, I will at some point, but for the time being, I think this should be good enough. Alright, so now we're going to talk about structures. So what exactly are structures? So let's go back to our tracker example, right? So we had the idea about that we were going for runs every day and we wanted to track it over 30 days. But what if the time of our runs wasn't the only variable we wanted to store? So for example, we have time. Say our time for the first day was 25 minutes. Maybe we wanted to measure our heartbeat, right? BPM. Our BPM was maybe, say for example, 80 or maybe 90 or something like that, which is pretty calm. So we had 90 for beats per minute. Maybe we wanted to also track our maybe the heat, the temperature of the day. So maybe we want to store a float as well. So maybe the temperature, maybe it was 23.4 degrees Celsius. Okay. So what if we wanted to group all this data together in one place? Because as you can imagine, putting underscore one day or storing these all in variables, so like say we want to do it over 4 days, that's quite a lot to manage, right? There's 3 arrays here we're managing. What if we wanted to group these together so we could have an array of one structure instead of having these 3 different arrays here? And we can absolutely do that with structures. So let's actually create a structure for our tracker here. So in order to do that, we need to create a structure. So at the top of our main function, we need to create a structure. So struct is our keyword, and we're going to say tracker. Okay. And we open up our curly braces, and we can put our variables in here. So we can say we want to have a tracker that contains our time, a tracker that contains our beats per minute, and also the temperature of the outside, which is going to be temp. So how do we actually create a tracker now? We've got a structure and we know that these are all variables that are collected together. How do we actually we'll create one. So let's do struct tracker, and let's create this tracker here like this. So we're gonna give it a time, which the time is going to be, say we've got 13 minutes, our beats per minute was 88, which is pretty low, and 23.4 degrees Celsius. Okay, so that's how we can create a tracker for day 1. Okay, and let's actually start to access some of these variables. Okay, so what if we wanted to do the time, which we're going to do here. We access the variables from this by doing tracker, point, and then we do time, and that will give us the time. We can also do printf. We can do beats per minute. Again, I need to do the new line character. I'm forgetting that. Tracker dot beats per minute, and we can finally do a printf of the temperature, which is now a float. So we need to do tag f and then do tracker dot temp, and let's see if this compiles. Oh, expected a colon before int. Ah, of course, I forgot 2 things. So first of all, I forgot to give tracker our name, so we're going to call it tracker, like so, tracker. And the reason this messed me up is I'm going to show you an easier way to do this so that you don't have to actually do struct, actually use the struct keyword. So essentially what we've got here is struct, and also we need a colon at the end of our structure at the top here, and that should compile fine now. And there we go, we've got our time, we've got our BPM and our temperature all in one variable. Again, just to reiterate, I made a wee mistake. Had the semicolon at the back end of this, and also we had to give our tracker a name. Now, it's kind of annoying that we have to use this struct, and we can use something in C called type definitions. So we can stick type def in front of this, and it basically says, hey, give this type structure tracker a different name, and we can actually just give it the name tracker. So after our curly braces, we can do a tracker like that, and that will do the same thing. So now all we need to do instead of struct tracker is just use tracker, just like if it was an integer, like so, or a float, we can just say now it's a tracker, and we can compile this code right now and run it again, and the same thing will happen. So let's go back to Vim, and again, let's say we wanted to create an array of our you know, trackers. So for example, we wanted an array of our trackers. So say we wanted to record 2 days, because that's going to be a bit much for me to write. So in order to do this, let's just make this nice and tidy. So say that we had another day that we did 15, we had 95 beats per minute, and the temperature was 18 degrees Celsius. Okay, so now we've got an array of our tracker, and then to get the first day, what we're going to do is we're actually going to use a wee loop. We're going to keep this, and we're going to do a loop just to iterate through this, so bear with me for the time being. Hope you guys are enjoying the music. Okay, so we're going to use I for the index to show us what day we're talking about, and also we need to index our tracker as well. And this should hopefully compile. Ah, okay. There's a couple of things that I got wrong here, so I'm being very messy today. Okay, so comma, and also we needed to take the int. I don't know why I involved the int there. Okay, so let's clear this up, GCC, and run it. So there we go. We've got the first time, our first day, which is by 0, and we've got the data for that one, and then we've got the data for the second day as well. So that's basically structures in a nutshell. It's just a bunch of variables that we can have together. And of course we can do way more powerful things with this, right? We can also have a structure within inside a structure as well. So we could do tracker and actually have a tracker stored within the tracker. We usually have a pointer within a structure to another tracker. So like for example, previous day. And we could have a tracker that references the previous day or perhaps the next day as well. But previous day would probably be more accurate. But that's a little bit more advanced, and we're only doing an introduction today. So that's structures.
Okay, welcome back, and this is going to be our final topic, and it's character arrays. I know, so sad, we have to finish this here. There are more topics that I'll be talking about in other videos, but I think this will be a good ending to the whole tutorial. So we've talked about integers, we've talked about floats, and we've talked about characters. But how do we store a string of characters? So like a sentence, for example. Well, we do this with arrays of characters. So let me show you how this is done. So I'm going to create a character, and I'm going to say welcome, and it's going to be an array, and we're going to equal this to quotation hello world. Perfect. So what this is basically is that we're going to store this string hello world into this array. Okay, but here's the thing. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 characters. Why is there 13 characters in here that we're storing into our array? So 13 is going to be the size of the array. Well, because this is what's getting stored inside the array. H, E, L, L, O, space, W, O, R, L, D, exclamation mark,
But also we have this thing called the termination character, or null bit, whatever you want to call it, that basically tells us that we're terminating the string, and it's represented as a \0. So this is actually what gets stored into our character array. And whenever we're dealing with strings, we always have to include this termination character, simply to tell any other program, hey, that we're finishing. So if we wanted to print this out into the terminal, we could do %string, so s, and then we would print this out. So let's do welcome, and let's see how this prints. So let's clear this. Let's compile the code with gcc main.c tac o main, and print this out. And there we go, we've got our string. So what happens if we want to store this manually, okay, without the termination character? What would happen then? So let's try this right now, but I'm going to do a smaller example just so I don't need to type out everything again. I'm just going to say hello, right? But hello, we're not actually going to store the not termination character. So let's compile this code and see what happens. Okay, so do you see how we've got this weird output with a tab, I think a space and an A? Well, essentially we haven't told printf where our string finished. So it's going to keep on reading memory until it finds something to terminate our program. But if we do it this way, where we add the termination character at the end, it will actually give us the correct output. So let's compile our code, and we get hello with no weird crazy A or tabs or spaces. So it's very dangerous when you're dealing with strings if you don't have the termination character at the end there. So always remember that's what's happening when we do things like hello. There's always that implied termination character at the end. To give you a quick example of what's going under the hood of printf, so you can see why we need the termination character, I'm going to create a very simple program. But first of all, we're going to change our character array instead to a pointer that points to the start of an array. So remember how our hello is just basically an array with the termination character on it. So we've got H, E, L, L, O, and then the termination character. And that's basically what we're assigning into welcome. Well, what we're going to do now is say, oh, we want to make our welcome a pointer that points to H, okay? And then the next, if we do welcome +1, which is the same as doing this, then that will point to E. If we do welcome +2, +2, then that'll point to L, and etc, etc. So if we do welcome +1, again, this will do E, and it's the same thing as an array. So we can actually use arrays and pointers in a similar kind of fashion. And what I'm going to do is an example of kind of what printf does under the hood. And what we're going to say is while welcome does not equal the termination character, okay, while it doesn't equal the termination character, because remember right now it's pointing at the capital H, we're going to put the character, we also need to dereference our welcome to make sure we actually get the character. We need to output our character to the terminal, welcome, and also after we've done that, we're going to add 1 to it. So we're actually going to move to E next, and then we're going to output E, and then we're going to go to L, then output L, L, O, and then once we finally hit that end termination character, we can stop printing. And essentially that's why we need the end termination character. So let's see this working in action. And there you go. Alright, so that was an example of what actually happens under the hood. Again, it's not exactly what happens, but it's an example. So that's character arrays.
Alright guys, and that is it. That is your relaxing introduction to C. So, where do you go from here? You now know the basics behind C, but there's still some things that I haven't covered here. And if you want me to do a video on them, sure, I can do a video on them, absolutely. So the two topics I would say to go on from here would be input output, properly working with files and being able to write to them, read from them, etc, etc. And also memory allocation. Now memory allocation can be quite a tricky job if not done right, but it's definitely an area in C that you need to master as well. And again, since this is only an introduction, I've not included it here. But again, this should be enough for you to get started and getting, into programming. So I hope you enjoyed this. If you liked it, please give me a like, and then subscribe as well. If there was anything you hated, please give it a dislike and comment on the section below and tell me how I can improve these relaxing introductions. Okay, so until next time, bye.